Hi folks, this is Shefik. In this video we are going to talk about event-driven architecture and its implementation in Python and Kafka, and in its consumer side we are going to have two options. We are going to implement it with Flask and also FastAPI. But before we start, please like the video and do not forget to subscribe to the channel to stay up to date with the latest videos. Also, your comments are more than welcome. Thank you for your all support in advance. First things first, let's discuss what is event-driven design. Have you ever wondered how Starbucks manages its queues so efficiently? You walk in and the barista takes your name and order, then write it on a cup. That's their role. It's quick and focused. The cup is then passed to another barista whose job is to prepare your coffee. Meanwhile, someone else may be restocking your coffee beans to ensure supplies never run out. Writing your name on a paper cup is quick and effortless, much like the producing phase of event-driven architecture. On the other hand, brewing the coffee takes more time, similar to consuming and processing phase. And just like the resumable infrastructure of event-driven systems, even if the barista's change shifts, the next barista can simply pick up the cup waiting on the shelf and continue brewing without any disruption. As an use case, we will implement analyzing facial attributes such as age and gender for multiple faces in a single image. The source code of this experiment has already been pushed to GitHub. You are able to pull it from my GitHub profiles, EDA and FastEDA repositories. EDA as its implementation with Flask. On the other hand, FastEDA is its implementation with FastAPI. On the other hand, we are going to use Kafka as a broker in both repositories. I pulled the source code of this experiment into my local environment, and I'm going to basically run in my project folder docker compose up firstly. This is going to get the Kafka and its UI up in my local. Thereafter, I'm able to produce and consume messages to Kafka. Once Kafka is up, I'm going to access its UI on localhost 8080 Pro, and Kafka UI is up, as you can see. Secondly, I'm going to go to scripts folder under my project repository. Thereafter, run the service.shell. This is going to get the core service up and it's going to use the Kafka. Once I see application started message, I'm going to confirm it. Localhost 5005 port and my EDA service is up. If you check the content of the service shell script, it's going to use Unicorn to get my Flask service up, and it also uses two workers. This means I'm able to process messages in two parallel, and if I want to process them in more cores, I can increase just this number, just the configuration in my service definition. And if I get the service up in many servers, then it's going to use many servers cores. So scalability is very easy in this infrastructure and in this approach. Finally, if you check the test shell script under scripts folder, it has a HTTP post example for the service. I'm going to run my core service. I'm copying this command into another terminal. Thereafter, as you can see, post/analyze endpoint is called, and it found 64 faces and it's processing each face one by one. As you can see, worker number is also mentioned. All those analyses handled in worker 7. So it's a sequential approach. It's running right now. It's not in parallel. All 64 faces analyzed single core, even though I have 12 cores in this machine. Let's check the source code, and here in the service py files under core module, I have an analyze method and it extracts faces from the given image, and here it finds 64 different faces. Thereafter, we have a for loop here, and we are going to analyze each face sequentially. In production, We generally try to avoid long running for loops, especially in Python, because Python behaves differently from JavaScript. In this regard, JavaScript can process for each loops in parallel, while Python runs them serially by default. Of course, you can use multiprocessing to parallelize Python tasks, but that approach is limited by the number of cores on a single machine. On the other hand, event-driven architecture allows us to scale beyond a single machine. Instead of processing everything sequentially, we can distribute work across multiple servers and take full advantage of many cores on each machine. Here, instead of calling analyzed extracted face method directly, I'm going to feed this payload to Kafka, and another task is going to consume messages from Kafka. And in my roots level in the core module, as you can see, I have a bus. This is going to consume messages in the faces.extracted topic. So here, instead of calling analyze extracted face method directly, I'm going to feed messages to this topic, and this is going to consume messages from that Kafka topic and call that method directly. Let's implement this. I commented calling analyze extract face method here. Instead of this, I'm going to use its event service, and event service has produce method. Here I'm going to set its topic name firstly. As you can remember, I'm going to use this topic faces.extracted. Secondly, I'm going to set key argument. This is not so important right now. I'm going to use extracted face key. Normally, Kafka distributes messages into different partitions by its key, but here I'm setting its partition value randomly, so it's not important in my experiment. And finally, I'm going to set the value. This is going to be the payload. Same payload I used here. Firstly, request ID is going to be request ID, or if it doesn't have, let's set not available. Secondly, I'm going to set the face index. It's going to be IDX again. Thirdly, I'm going to set face ID. This is going to generate a random UUID. Thereafter, I'm going to set face K, and this is going to be encoded face, similar to this sequential module. And finally, I'm going to set shape K, and it's going to be face.shape. It gives the number of dimensions of my numpy array. Thereafter, let's print a log under logger.info. That's set IDX. It starts from 0, that's why I added 1. This number face set to send to Kafka topic. Let's set the name of the topic faces dot. Instead of calling this module directly, I'm going to move that payload to a Kafka topic, and here in roots level, I'm going to consume that topic, call this analyzed extracted face. Let's rerun our service. Once I see the application started message, as you can see, it is printed in worker 2 and worker 3. This means it's running in 2 parallel. I'm going to run same HTTP post message. As you can see, post analyze is called in worker 3. This is decided randomly. Thereafter, in worker 3, it extracted faces, and there are 64 faces because here I implemented this directly. I didn't feed it to Kafka. Thereafter, in this for loop, I fed every payload to Kafka. And if you check the time, same minute and same seconds, each phase is fed to Kafka. Thereafter, and roots level, I'm going to consume messages in the Kafka side. And as you can see, for instance, first phase analyzed and it's handled in worker 2. Second phase analyzed and it's handled in worker 3, because I have 2 workers in this experiment. I may have more, but I just have 2. As you can see, I analyzed all phases in 2 parallel. That's all. And it's handled much faster. Herein, let me show the messages in Kafka side. In faces extracted topic, I have many messages, and this is an example. Request ID as randomly generated UID, face index, face ID, and base 64 encoded face. And finally, it should have shape value, and this is the shape of the detected and extracted phase. In other words, whenever I call this produce, that payload, that message can be trackable via Kafka. Even if I just suppose that just after the producing message, my service went down. Whenever it gets up again, it's going to continue to consume messages. So in other words, it's resumable. In summary, we focused on event-driven architecture in this video and implement it with Python and Kafka. And as a consumer, we used Flask, or we can use FastAPI to consume messages from Kafka. Besides, we discussed the idea of event-driven architecture, why we prefer it instead of sequential approach, especially in Python, and its role in highly scalable software infrastructures. If you do like this video, please like it and do not forget to subscribe to the channel. And if you make comments, I'd be grateful. Thank you all for watching and see you next time.